So this is from question number 20 is from IIT JAM 2022 mathematics paper. So for every this P belongs to this matrix of 5 by 5 matrix, and Ij is belong to 1 2 3 4 5, and let P of Ij denote the I and j entity of P. Let S be another matrix which is belong to this P of this the same 5 by 5 matrix, where this Pi j is equal to PRS. For IGRS belong to this 1 2 3 4 5, and IER equal to J plus S. So we can, let us take one matrix of a 5 by 5 matrix. So the matrix BP, so we can write it as P11, P12, P13, P1415. Next is P21, P22, P23, P24, P25. So we delete this third row. Sorry, so it will be P33 and it will be P34. P42, P43, P44, P45, and the last row is P51, P52, P53, P54. So this is a 5 by 5 matrix. Okay. Right. So here we have a condition. So the condition is given as in this way. So I plus R is equal to J plus S. So where this P of Ij is equal to P of Rs. So whatever the elements in P, that will correspond to elements in S if this condition satisfies, right? So from here you can see the diagonals actually, P11, P12, P13, P1, this P11, P22, P33, P44 and P55. So they all follow this I plus R and J plus S relationship. So we can write in this way, this P11 equal to P22, P33, P44 and P5 equal to this P5. So all the diagonal elements will be equal. Okay, so this is the first one. Now from the matrix we can just say like this, that now we have to find the each of the element. This P11 is given, so now we will find P12, P13, P14 and P15, and the relation we will just want to see this which of these elements satisfy what elements of this, and following this relation. So this relation is important, I by I plus R equal to J plus S. So from here we can write in this way that P of 1 2 can be written as P of 2 1. It also can be written as P of 3 2. So because this is I plus R, and 1 plus 3 4, 2 plus 2 is equal to 4. Similarly we can also write P4 3 equal to P4 5 4. This for the P1. For the next element P13, we can write it as P31, P42, P53, right? Similarly, for P14, it is equal to P41, is also equal to P52, and finally the P15 is equal to P51. Okay, so this is we find from the first row, elements of the first row, and we find the relation between elements of other rows. Okay, similarly we can find as a P21. So here we'll find the first P21, then P23, 24, 25. So in case of P21, it can be written as this, it is equal the same as P23, P34, P45, right? P21 you can write this way. P23 can be written as P32, P43, P54. You can see this plus 4 plus 2 6, 3 plus 3 6, 2 plus 5 7, 4 plus 3 7. Okay, similarly we can write P24. So P24 is equal to this P31, P42, P53. Similarly we can write P25 is equal to P41 in this P52. Okay, now write for the elements row 3. So we can write it over here also. Okay, so that is P31, it will be equal to P35, P32 is equal to P34 is equal to this P45, P34 we can write in the same way as P43 is equal to this P54, and the last one is P35 is equal to this P42 is equal to P53. Okay, now so here we have defined, so we can consider this A as A1. Okay, so this is A1, A2, A3, A4, A5, right? So from here we can write what are the elements belong to this. So P21, if P21, so we can write it as, so here it will be P21, so it will be A2. Okay, P23, it is also A2. What is P24? A3. P25 is A4. Just consider any of the terms. Suppose this P25, so we have this P25 going to P41, so this is here is P41, so it is A4. Okay, similarly for P31, so we got P31 over here and it is A3, and we just write it as P3. Okay, similarly for the elements in the third row, So for the P31 it will be A3, P32 it is A2, P34 it is A2, and P35 is also this A3. So now construct the S matrix. Okay. So from all this you can construct this S is equal to, so the all the diagonal elements will be A1, right? So I can write it as this A1. This is also the P11 position. So it will go like this, P1 to 1 3. So we have considered the A2, A3, A4, A5. So P21 we have written as this A2. So here it will be A2, P2 to A1, P23 is also A2. Here you've got, yes, A2, A3, A4. So remaining term will be A2, P31, A2. So it will be A1, the diagonal, A3 and A4, A2 and A3. Okay. And we can write it as this fourth row as A4, A3, A2, A1, A5, A4, A3. Okay. So this is the matrix 5 by 5 S matrix. Okay. So here we will find this, all the diagonals are A1, and remaining elements we have find it out of by through this. Okay. Now see the first row. How many elements are there in the first row? So in the first row we have 5 elements, right? And see all other remaining rows. So in any of this row, if we find any new element, so that will be added. But here in our case, all the elements, whatever the elements are present in the remaining of the rows, it is already present in the first row. So here we can find the dimension of S. So dimension of S is 5. Okay. Now check with the options. First option. So this first is the S is a subspace of the vector space over R of all 5 by 5 symmetric matrices. So actually you can see that whatever the S that we have defined, the S matrix, so it is a set of symmetric matrix, right? So it is a symmetric matrix 5 cross 5. So any symmetric matrix can be a subspace of any 5 by 5 cross 5 matrix, right? So in our case the option A is correct. The S is a subspace of the vector space over R of all 5 by 5 symmetric matrices. This is correct options, and we have to find which one is the false, right? So the option B is the dimension of S over R is 5. So I have already find that. So dimension of S is 5. Option C is dimension of S over R is 11. It is the wrong option. Okay, because dimension of S is already 5. We have given this is we have already find out. And what is the last option? So if P belongs to S, then all the entries of P are integers. Then 5 divides the sum of all the diagonal entries of P, right? So let us check with the S matrix also this. So let us check what is the sum of the diagonals. So it is all A1. So the sum of the diagonal here it will be 5 of A1. So whatever be the value of A, if it is multiplied by 5, it will be divided by 5 in case of S. Similarly, if P belongs to S, so it will the same for this set P, right? So option D is also correct. So whatever this so in this, for this particular sum, the which one of the option is false. So the dimension of S is 11, so this is the false option out of the 4, so we will tick on this option C.